In this practical, we investigate how light changes direction when it passes from air into a glass block and then back into air. When light travels from one material to another, it bends, and this bending of light is called refraction. The amount of bending depends on the refractive index of the material. A material with a higher refractive index bends light more. To explore this, we shine a narrow ray of light at the glass block and draw the ray paths on the paper. At the point where the light enters the glass, we draw a normal line at 90 degrees to the surface. We then measure the angle between the incident ray and the normal, and that gives us the angle of incidence. When the light enters the glass, it bends towards a normal, and when it leaves the glass, it bends away from the normal. We measure the angle between the refracted ray and the normal to get the angle of refraction. By repeating the experiment for several angles of incidence, we can see a clear pattern that the higher the angle of incidence, the higher the angle of refraction. Using the angles, we can calculate the refractive index of a glass using the formula refractive index equals sine of angle of incidence divided by sine of angle of refraction. When plotted on a graph, the relationship between the sine of the angles gives a straight line which confirms the calculation. This practical shows that different materials bend light by different amounts because each material has its own refractive index. Understanding refraction helps us explain how lenses focus light, how prisms spread colors, and how glasses help people see clearly. By measuring the angles carefully and drawing accurate ray diagrams, we can prove scientifically how light behaves when it enters and leaves a glass block.